Welcome to Unit 6, Inference for Categorical Data on Proportions. This is topic 6.7, Potential Errors when Performing Tests. So we just got done finishing up all the teeny tiny details, all 4 steps that go into a test for a one sample z-test for a proportion. And now we want to talk about some potential errors that could occur. Now, what errors could there be? This topic is not about errors that you could make in conducting a one sample z-test for proportion. What I mean by that is I'm not talking about human mistakes, like you forgetting a sample or you rewriting a condition the wrong way, or maybe that you use your calculator wrong and you get the wrong standard deviation, or you calculate the z-score wrong because you just had a brain fart and didn't know what to do. I'm talking about real-world implications if the wrong conclusion is made. So you might not quite understand what I'm talking about right now, but by the end of this video, you definitely will. So when we think about the end, the conclusion of a test, we are either going to reject the null, meaning there is evidence that goes with the alternative, or we fail to reject the null, which means we do not have evidence to go with the alternative. Now, when a conclusion is made, you could potentially make one of 2 types of errors. So a type 1 error, and just so you're aware, for some reason we use a Roman numeral 1. You could use O-N-E. You could even use the number 1, but usually we use a Roman numeral 1. I don't know why that is, to be honest, but this is a type 1 error. Now, a type 1 error occurs when the null hypothesis is in actuality true, but we reject it and believe that the alternative hypothesis is true. In short, a true null is rejected. So in actuality, the null hypothesis is really true. So the error is that we reject it, that's wrong, and we believe the alternative is true. So if we go back to the criminal court analogy that I've been using in the last couple of videos, this would be sending an innocent man to jail. Obviously, we've made the wrong decision. So again, in a court analogy, the null is that the accused person is really innocent. And a type 1 error is when that null really is true. He really is innocent. But the error becomes that we send that person to jail. We reject innocence and we go with the alternative that they're guilty. Honestly, this happens, right? This happens all the time. I was just reading a newspaper article the other day that in Ohio, in the recent decade, there have been 88 wrongful convictions. So it does happen, right? But understand this. The right decision has been made thousands of times, right? So if you go back the last decade in Ohio, and you look at how many times was a person who committed the crime properly sent to jail for that crime, that happens tens of thousands of times. But the big flashy headlines come in the very few cases where an innocent man is sent to jail. Obviously, that is a problem, and that is making the wrong decision. Now, the probability of this type of error is equal to your level of significance, alpha. So when you set your alpha level, for example, to 1%, you're basically saying that there is a 1% chance that you make the wrong decision. There is a 1% chance that you reject a null that was truthfully correct. Now, the flip side of that is if there's a 1% chance you'd make the wrong decision, there's a 99% chance you make the right decision. That if the null is true, you fail to reject the null and you keep it, right? So again, this is very small. These types of errors do not happen. And the other thing I want to mention right now is that, you're never going to know if you made one of these errors. These are all hypothetical. If I knew what the truth was, then I wouldn't even need a test because I know the truth. Why would I need a test when I know the truth? If I knew, maybe I had some special psychic powers and I knew that this guy really did or really was innocent, he really was innocent, then I would tell the police and I would hope a trial never even happened. So this is all hypothetical, but this does happen. Sometimes a null hypothesis that's true gets rejected, and we go with the alternative. And again, the probability of this happening is the alpha level you choose. So the flip side of that is again, in this example, the 99% of the time where the right decision is made. So that's a good thing. All right. A type 2 error, and again, notice the Roman numeral number 2. You could use the word TWO or 2, but we typically use the Roman numeral number 2. A type 2 error occurs when in actuality, the null hypothesis is false and the alternative is true. So in actuality, the alternative is true, but the error is we failed to reject the null. So in short, a false null is kept. So the null is wrong, the alternative is true, but we keep the null. We failed to reject the null. We don't say that the null is correct, we keep it. So in our criminal court analogy, this would be sending a guilty man free. Obviously, we've made the wrong decision, right? And again, this happens too. If O.J. Simpson is a very classic case where a lot of people do feel that a guilty man was set free. That's just an example. And those types of things make big headlines. But again, usually if somebody's guilty, they go to jail. Okay? So that's what happens the majority of the time. But every now and then, there's just not enough evidence to send somebody to jail. Even though we truly believe they're guilty, there's just not enough evidence to send them to jail. So again, this does happen. Now, let's be obvious, okay? We would prefer not to make a type 2 error, right? If somebody's guilty, we want to send them to jail. So we would prefer not to make a type 2 error. Well, we actually have a vocabulary word for this. It's called power. And who doesn't want power? So this is a statistical term, right? Everybody knows the word power in a lot of other contexts, but in statistics class, the word power is actually a vocabulary word that has a statistical meaning. The power of a test is the probability that a false null hypothesis is in fact rejected, like it should be. This is making the right decision when the alternative is true. Power is a good thing. When we reject a null that's wrong, we have a lot of power, okay? So power is the probability we reject the null when it's really false, okay? Now, this is the complete opposite of type 2 error, okay? Let me remind you, type 2 error is that the alternative is true. The guy is guilty, but the error is that we don't send him to jail, so we failed to reject the null. So power is doing the right thing. Power says you're guilty, the null's wrong, the alternative is true. We're going to go with that. We're going to conclude that. That's doing the right thing. And the probability that that happens is called power. Now, this can all be a little bit confusing. So I have found that this flow chart or this tree diagram for some students really helps make sense. So the first off is what's really true. What is really true? Now, again, this is all hypothetical because if I knew what was true, I wouldn't even conduct a test, right? If I knew that Kelly was not the murderer, then I wouldn't even put her to trial, right? I would let her go free. Or likewise, if I knew Kelly was the murderer, then I would hope that there was no trial to begin with and she was sent to jail. So again, all hypothetical here. So what could really be true? Well, the first option is the null hypothesis really is true. So this is right here, right? This is this branch right here. The null hypothesis is really true. The alternative is wrong. Now, if that's in fact the truth, two things can happen. One is we fail to reject the null. This is the right decision. This is a good thing. This is awesome, right? The null's true. Well, then we should fail to reject it. We should not go with the alternative. We should keep that null. This is the right decision. But here's where we have a type 1 error. We reject the null. Now, this is the wrong decision. Remember, the null's really true, but we reject it. So we believe the alternative is true, but it's not. The alternative is not true. The null's true. This is a type 1 error. And again, I mentioned earlier that the probability of a type 1 error is alpha, which makes 1 minus alpha the probability of doing the right thing. So if you're going to be, say, 5% for your alpha level, 5% significant, then that means that you're going to make the right decision 95% of the time. This is great. So again, this branch is of concern to us, this type 1 error branch. Obviously, we don't want to make an error right here, but that doesn't happen a whole lot, right? And we could even decrease that to 0.01 to reduce type 1 error. And then that means we have a 99% chance of doing the right thing. So again, those two numbers are definitely connected there. All right. Now, the other possibility is that the truth is that the null hypothesis is really false. The alternative is what's true. The null is false. Now, if this is in reality what is happening, then we could reject the null. This is the right decision. The null's wrong. We should reject it. We should go with the alternative because it's true. And this is power. This is doing the right thing. This is power, okay? But we could make the wrong decision, and this would be when we fail to reject the null. If we fail to reject the null, that's the wrong decision. Here we're going to keep a false null. This is a type 2 error. Now remember, just as these work in opposites, alpha is the probability of type 1 error, so 1 minus alpha is the probability that you make the right decision when the null is true. So power is what we call doing the right thing. If the null is false, you should reject it and go with the true alternative. That's power. Therefore, the probability of a type 2 error is 1 minus the power. So 1 minus power. Now, here's something important. I'm never going to ask you in this class to find the probability of power. We're never going to focus on that. It's not in our curriculum. Now, if you take any stats classes in college, then you may actually talk about how to calculate the power of a test. All you need to know right now is that the power of a test is rejecting a null when it really is wrong. That's a good thing. Don't worry about finding the probability of it. Likewise, type 2 error is 1 minus power. That's the opposite of power. Now listen, power should be really good. You should have lots of powers. Let's just play a pretend game. Let's just say that you have a 92% chance to do the right thing. The null's wrong, you should reject it. Well, that would mean that you have a 0.08 or 8% chance of making a type 2 error. But again, you're not going to have to worry about these numbers. Now, these numbers up here, you're going to know, right? Because alpha, you determine. You pick 5 or 1%. So that means you will know the probability of doing the right thing when the null's true. It's when the null is false that, again, I'm not going to really ever expect you to know the exact numbers. You just have to understand the idea of them. Okay, so please note, I've been mentioning this already, but I really want to make this clear. In any problem, we will never know if you made the right decision or not. This is all hypothetical. I mean, just think about it. Again, I said this earlier. If we knew the truth, a test wouldn't even be needed. You just need to know the fact that these potential errors are out there, but you do not have to worry about them actually occurring or not. Don't stress about it. Just know that there's always the potential for them. All right, so what do you really need to do? You need to be able to understand the possibility of these errors in context. You need to be able to explain them in context. So we're going to practice that in a moment. And you also need to understand possible consequences of these errors in context. And again, we're going to explain that in a moment. And you also need to understand the basic idea of their probabilities. Don't focus so much on actually calculating any kind of probabilities here. Just know that these things do exist. They don't exist at a very high probability, but they do exist. All right. So what I'd like to do right now is walk you through a non-statistical example. This problem has nothing to do with stats. It's more just kind of words, but this allows you to get the basic understanding down. So consider a medical test that will check if a patient has diabetes. Who knows? Maybe it's a blood test, maybe it's some type of scan, whatever. So the null hypothesis is no, the patient does not have diabetes. Or the alternative is no, the patient does have diabetes. And again, this is a medical test that's going to make this decision. All right, so what would a type 1 error in context be? And what's the consequence? And what's a type 2 error in context and a consequence of it? So I'm going to show you some really nice typed up answers in a moment, but I just want to kind of freely talk about this for a moment. So remember, type 1 error is the null is true. That's something you will have to memorize. The null is true. So the truth is that the patient does not have diabetes. So the error is we conclude that they do. So we reject the null. We go with the alternative that they have diabetes, but they really do not. A type 2 error is the alternative is true. The null is false. So the patient does have diabetes, but the error is that we keep the null. So we fail to reject the null. We believe that they do not have diabetes, but they really do. Obviously, those are both mistakes, and we don't want them to happen. Okay, now here's a little bit nice. You can actually see this nice context here. So type 1 error, the patient does have diabetes. The null is true. But the test rejects this and concludes that the patient does have diabetes. So the patient does not have diabetes, but the test says they do. So a possible consequences are that the patient will now have maybe anxiety because he or she believes they have diabetes, and that's not, fun to be told that you have diabetes. And maybe the patient starts taking medication that's not necessary. So the doctor says, okay, you have diabetes. You got to start taking all this medication because you have diabetes. But the truth is they do not have diabetes. So the patient's taking unnecessary medication, and maybe that harms them in some way. So lots of consequences there. Type 2 error, the patient does have diabetes. The null is false, the alternative is true. But the test fails to see this and concludes that the patient does not have diabetes. So a possible consequence of this is that the patient does not receive the proper medication that he or she needs for help with the diabetes that they really do have. So to me, a lot of times you might debate what's worse, a type 1 or type 2 error. In this case, a type 2 error I would think is worse because I really do have diabetes, but my doctor didn't see it that way. So I need medication to help me, but I don't get it. Whereas in a type 1 error, okay, at the very end of the day, at least the truth is I don't have diabetes. So yeah, I take this medication. I'm all anxious because I think I have diabetes, but at least the truth is I don't. If there's any silver lining in that. Obviously, they're both mistakes, and what I'm expecting to be able to do is explain what these types of errors are. Now, is it going to happen? Yes or no? Don't worry about that. Just understand the concepts. All right, so let's talk a little bit more about power. Now, just like in any situation, we always want more power. Who doesn't want more power? So here's the deal. If the null hypothesis is false and the alternative is true, we obviously want to make that conclusion, right? So if the person really did commit the crime, they're not innocent, they really did commit the crime, obviously we want to send them to jail. So this is power, doing the right thing. Guilty person goes to jail. So the big question is, how do I get more power? Well, there's 3 ways. Increase your sample size. Bigger samples will always be closer to the truth with less variation. So if the alternative is in fact true, a bigger sample will make that easier to see. Remember, we've been talking for weeks that bigger samples vary less. So if the alternative is really true, a bigger sample should show that better. So if that's what's true, we'll see it with a bigger sample. A small samples, they vary a lot. So we might not necessarily see the truth in a small sample, but in a bigger sample, you will. So that's one guaranteed way to get you more power. All right, the second thing you could do is increase the significance level of your tests, alpha. If alpha goes up, then the probability of a type 2 error goes down. Okay, now this isn't necessarily recommended, and I'll explain why in one moment, but with a higher alpha, you will be more likely to reject the null. Think about that for a second, right? Alpha is like the threshold of what you consider to be significant. So if you would do something crazy, like raise your alpha all the way to 20%, well then you're going to reject the null more often, because anything below 20%, you're going to reject the null. As opposed to using an alpha of 0.01, you're not going to reject the null very often. You're being very strict. You got to be under 1% to reject the null. So if I increase my alpha, I'm giving myself a higher chance to reject the null. And if that's what needs to be done, then that'll do it. But I don't necessarily like this option, because if you increase alpha, well, then you're increasing your chance of a type 1 error. So increasing alpha does work. It definitely will give you a better chance of rejecting the null. And if it's wrong, it should be rejected. But again, it's at the consequence of raising type 1 error. So don't know if that would necessarily be something you'd want to do, but I need to talk about it. Now, the third way actually makes a lot of sense. When the actual truth is further from the null, hence our sample statistics should be as well, you will have more power. Now, this makes a lot of sense only if you take the time to understand it. So I set up a quick null and an alternative real quick. So the null is that P is 0.22. The alternative is that's 0.22 or greater than 0.22. So if the real truth, right? Remember, if this is wrong, I want to reject it. I want to go with the alternative. What I'm saying is that if the null is wrong, now if the actual truth is really far from the null, like let's just say the actual truth was 50%. Well, then I would assume a sample will show me that. And if a sample shows me that, then I'm going to reject the null and go with the alternative that it's clearly more than 22%. So the further the actual truth is from the null, the better chance I have to see that and reject the null. And again, you could think about this on the opposite. Like if the actual truth was 0.23. Now, technically, that is more than 0.22. But it's really not that much more. So I might not see it, right? A sample, which is naturally allowed to vary, a sample might not show me that because samples are going to vary. So, I should reject the null. I should go with the alternative because the truth is more than 22%. But if the truth is only 23%, it might be harder for me to see that. But if the truth is really far from the null, well, then a sample should tell me that, and I should see that. Hence, I should reject the null and go with the alternative. So the best ways to get more power is, number one, increase your sample size. That's always going to work. And again, you don't really have any power, like you don't really have any direct control over what the truth is. But if the truth really is something further away from that null, you will have more power to see that and conclude that. All right. Let's end with a statistical example. Earlier, we did a non-statistical example with words. Let's do one that's a lot more statistical here. So a TV manufacturer builds TVs on an assembly line. Traditionally, 5% of all TVs assembled are defective and have to be fixed before sold. Okay. Now, 5% is acceptable, and the company knows that they could deal with it. Like at the end of the day, anytime you build something on an assembly line, there's going to be defective things. So the company's totally okay with 5%. They don't mind fixing that if it happens. However, the new manager of the assembly line, he's concerned that something is wrong and that more than 5% of TVs are defective. Now, if this is true, it would waste a lot of time and money because we would have to fix a lot more TVs, and that would not be very good for the company. So he plans to select a random sample of 210 TVs to test his claim. So his null would be that, no, everything is totally fine. The truth is 0.05. 5% of TVs are defective. It's not anything outrageous. Whereas the alternative is what this manager is wondering. This manager believes it's more than 5%. So explain in context a type 1 error and a consequence of it, and do the same thing for type 2 error. And then I have a final question. If the manager's belief is correct, if the truth is really that it's more than 5%, what can be done for him to make that right conclusion? All right, so here's my answers. Type 1 error and a consequence. Type 1 error, the null is true. Only 5% of TVs are defective. It's not more than that. However, the manager concludes that the proportion of defective TVs is more than 5%. So he rejects a null that is true. So he stops the whole assembly line. He tries to fix a problem that's not there. He would be trying to fix a problem that doesn't exist. So again, the null's true. It's only 5%. It's not higher, but he thinks it's higher. He panics. He shuts down the assembly line. He starts trying to fix a bunch of things, but it's not a problem. Nothing needs fixed. He just thinks it does. That's going to be an issue. Now, type 2 error and a consequence would be this. The truth is that more than 5% of TVs are defective. There really is a problem. The manager was right, but the error is he does not conclude this. He keeps the null. So he doesn't do anything to fix a problem that really exists. There really is a problem. More than 5% of TVs are defective. The assembly line should be stopped because there are way too many TVs that are being defective. And that means that the company's spending a lot of time and money to fix them. So, again, which one's worse? Well, type 1's going to waste time because we're going to stop the production line. But at least at the end of it all, the truth is that the company's fine. Nothing is wrong. Type 2 error, to me, is a bigger of a problem because there really is something wrong. The TVs really are more defective, and the company's going to waste a lot of money fixing all these broken TVs when maybe they should have stopped the assembly line and fixed it so this doesn't happen. All right, now the final question was, if the manager's belief is correct, if there really is more than 5% of defective TVs, what can be done for him to make the right conclusion? Now, this is talking about power. If there really is more than 5% of TVs that are defective, he wants power to see that and fix it. So first and foremost, he can increase his sample size. If he were to select more TVs to examine, he's more likely to see that it's more than 5%. A bigger sample size is going to always reflect the truth better. So if the truth is more than 5%, a bigger sample size will help him see that. Now, he can also increase his significance level when it comes to making his conclusion. If he were to raise his alpha level to say 10%, he would be more likely to reject. But again, this is going to increase type 1 error, so I don't necessarily think that I would go with that option, but it will work. Lastly, although what I'm about to mention the manager has no control over, is if the true proportion of TVs that are defective is really high, like 20%, then it should be easier for him to see this and reject this. Again, if the truth is something way above 5%, then you're going to see it. I mean, a sample should show you that. If the truth is like 7%, just a little bit high, well, yes, listen, 7% is more than 5%. We should reject the null, but maybe a sample doesn't show that because, it's really not that much higher. So what I'm trying to get at here is that if the truth is way far away from our null, then we should see that and reject the null. But again, the manager really has no control over this. So if I wanted the best answer as to what the manager could do to truthfully see that there are more than 5% of TVs that are defective, get a bigger sample size. All right, guys, that's it for this video. It wasn't too big of one, wasn't too long. Hopefully you understand all the concepts, and we'll be ready to work on some practice with it.